Hey guys, how's it going? Sorry for the costume change as far as the environment goes. I'm traveling and kind of handling a bunch of stuff right now. But I didn't want to keep putting off the videos, so I wanted to go ahead and post one for today. Mondays, we're still going to be covering the homeowner stuff. We are getting more into the round 2. We're going to be doing design. We will follow that up with like round 3 stuff when we start talking about engineers or start talking to engineers and some other stuff that kind of goes into all that. And then we are getting into things that are not residential homes for Wednesdays, which is going to be more like freeways, highways, roadways, more technical information with regard to residential homes, yes, but repair systems and stuff like that. But I did want to talk about something that homeowners still deal with all the time, and that is swimming pools. So one thing that you'll notice is a theme with legitimately everything residential, home, commercials, structures, liquefaction, railroads, freeways, everything. Probably about 85% of all the problems still have to do with water. Like, doesn't change. So the fun thing about dealing with the swimming pool is that if you have a swimming pool built into the ground, right, and then you've got a hillside here, literally everything we've talked about with homes as far as the slip plane and hillside creep and all that stuff is still subject to a swimming pool, right? Now, given a swimming pool is built in a backyard, typically, that usually means it's closer to the slope, right? And usually meeting that 1 to 3 rule that we talked about with the engineering and whatnot, very, very often swimming pools are subject to consolidation of fill soils, hillside creep, movement of slopes and stuff like that. So especially if this is built on a hillside, you're gonna run into issues unless they've got like the little mini piles down at the bottom built onto a grade beam to support the pool, right? For some lateral resistance and whatnot. A lot of the repair systems include embedding into bedrock down past the slope creep and so on and so forth. The reason why swimming pools are tough is because they've got all the subterranean piping systems that run drainage, right, all the way around. And any old pipes that you have, any earthquakes or seismic movements that have shifted the pipes and caused them to become disjointed, any cracks in the plaster over by like the light inside the pool and different things, all of this could create a moisture problem where the water starts leaching into the soil, right? And if it does that, it creates settlement or a pocket void and starts washing everything out, especially on a hillside. If you're not a flat lot, flat subdivision and all that jazz, it's not as much of an issue, but still could create a problem like that. Now, that is a problem that can be handled once somebody comes in and fixes the pipes, but it still doesn't change the fact that everything above and below is being influenced by the moisture that's being introduced into the soil. So not only do you have like slope creep, hillside slippage and consolidation of fill, and then you've got plumbing leaks just like a house, right? And you've got all of the exterior drainage and then the rain, and then if the exterior drainage doesn't properly move everything away, you can get settlement of the coping surrounding. If there's a retaining wall that's failing, there's a litany of different things that could cause a swimming pool specifically to settle, right? Repairing a settled swimming pool strongly depends on the construction of the pool. If you've got this grade beam and caisson system that goes down, it's gonna be really tough to pick that back up to level, right? Because that acts as an anchor down into the soil just as much as it does act as a resistance to the downward movement. So lifting a pool back up, usually you're not gonna have that particular support there, right? You're not gonna know that unless a couple things happen. 1, you get as-built drawings. 2, you get design plans. Or 3, you cut into it and find out, right? There's no real way to know that. Now, the cool thing about trying to lift the pool up is a lot of different construction methods can be used in order to stabilize a settling swimming pool. Each one deals with a variety of issues that could be happening in order to create the settlement that's happening on the pool one way or the other. Again, you could do the post and beam, the caisson and grade beam foundation system in order to support the bottom of the pool that embeds down into bedrock. It's one of the best possible repairs, right? On the flip side of that, you have to cut the bottom of your pool out in order to install this thing, right? It is one of, again, the most invasive, intrusive, destructive methods for stabilizing a swimming pool that exists, just like caissons on a house. So a lot of the rules are very much the same, even though we're talking about a swimming pool versus like the structure of a house itself. There's just a couple of different rules that apply to it also, right? If the swimming pool has a grade beam underneath it already, you can try to lift that using push piers, helical piers. You can try to do that. That's rough. Like, it's doable, it is, but it's rough. The first issue you'll have running into that, especially with a push pier system, is that push piers are end bearing and they rely on the weight of the structure in order to embed into bedrock, right? So if you got the shell of a swimming pool that you're pushing off of a grade beam in order to get the pier down into depth, and then you add 60,000 gallons of water to the pool after your pier's been stabilized, that additional weight will cause your pier to settle, generally, unless you manage to hit bedrock or embed it or whatever else. You could pre-drill it, that would be a reason. Anyway, so generally push piers is kind of tough. Helical piers, you can at least hit like a design torque and a design depth, design pressure, pretending those ghost loads exist that we talked about when we were talking about putting additions on homes and stuff like that. So you could design a helical pier to stabilize the pool once the water goes into the pool. That's entirely feasible, but really, really, really tough to just like cut everything out, pop these helical piers on. And that's assuming these grade beams exist already. You could put a new construction cap on there and then pour it into a grade beam. But at that point, I think you're probably better off just using caissons because you're already destroying your pool. Like the last thing that you need is, in order to do caissons, the last thing you need is a good drill to go down to a target depth, right? So at that point, I would just go with caissons. Mudjacking is an option, asterisk. So mudjacking or compaction grouting, which you can do with the cementitious grout, cement, sand, slurry, some other proved alternative, or HDPF, high density polyurethane foam. That's kind of like one of the preferred methods for all of us to be approaching a pool. But again, this is symptom specific, right? So the cool thing is instead of cutting out the pool in order to put and then like anchoring these big things on and pouring concrete and blah, 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 you're drilling for HDPF. It's a 5-inch size hole the size of a penny. Or for traditional methods like cementitious grout or cement sand slurries, you put like a, 1.5 to 2.5 inch size diameter holes. It's cool, whatever. And you shoot material in order to, you shoot material in, right, in order to displace the water, strengthen the soil, and ultimately create upward pressures. Now you can kind of already see from my drawing here where that starts to run into an issue is that if this pushes this way onto your slope, you could trigger a landslide. Terrible plan. So concrete is not my favorite, right? Especially in applications like this when you're looking at consolidation of fill issues, hillside stabilization, different things like that. You're adding 125 to 145 pounds per cubic foot of weight into soil that's already bad. The moisture generally has some problems trying to let the concrete dry, so cure times become an issue, and then you put like admixtures and adhesives in order to make that happen better, but it's still really, really heavy. You go to a lightweight cellular concrete, which is more cost prohibitive, but makes it, I don't know, a little bit more like polymer. But then you don't have the expansion, so you end up using more products. So concrete, kind of tough. You could end up filling the voids, you can end up stabilizing the pool, you could end up lifting it back to level even. The issue is now that you've pumped all of this concrete into the soil that's bad and now good, the soil, like if I pumped here and I stabilize all of this, right? So this soil is good now. This soil down here, which was good, which was rated for whatever poundage or PSI pressure of resistance that it was good with, now you put a ton of weight on top of that. And it's not good anymore, right? Plus the blowouts, plus the landslide, anyway. So I prefer lightweight high density polyurethane foam, HDPF. That's why we sell it. That's one of the big things about what we do. And as far as swimming pools, I mean, you got the guys over in Texas. They're doing 60 residential pools per year, right? And we're doing these all across the United States regularly. And these are things as far as like we've done in Laguna Niguel. We wound up doing a YMCA pool recently. We did a City of Kendrick had this World War II memorial pool. Coolest job ever. Check out the case study on our website. It was awesome. But really just sealing the entire pool, stabilizing everything underneath, filling the voids, making the soil stronger, and lifting it up. Things to be concerned about. If it is a leaking pipe, First thing I always tell people is check out your pipes. You need to do that because if there's a leak and you shoot foam, if it's a drainage line, you're gonna fill it with foam or concrete or whatever. And if it is a pressurized line, then it's gonna continue leaking water out. And if you never fix the problem, then it's gonna continue to exacerbate the issue and cause it to settle further, right? So imagine, like you have a leaking pipe, your pool settles, we go in, we lift it up for $20, $30, $40, $50,000, and then you have to go in and cut through your pool and our foam and the soil and everything in order to fix the pipe. Like, people don't appreciate that, right? So check out the pipes, make sure that they're not leaking, leaching, anything else like that. Plumber will do it pretty cheap, generally. If you do the work from the inside of the pool, you can do the work from the outside of the pool as far as compaction grouting is concerned, right? Very, very difficult to angle this off in order to get underneath the pool in order to facilitate upward lift, right? So you can do it, but you're very much limiting your lifting capabilities when you do it. Other than that, you should do the work from the inside of the pool, here and here and here and here, and right? And then you shoot straight through and you get a better seal and you can better control the upward force in order to facilitate the lifting. What this also means is that when we're done, you need to replaster your pool. There's no way around that except to do it from the outside, which may or may not work, right? Now, surrounding that, you also have the coping which surrounds the pools. Oftentimes you can get disjointed coping through and through, or you got like drainage systems or stuff that ends up becoming an issue. So you can shoot underneath the coping that surrounds the pool in order to fill the voids and then realign all the disjointed slabs. Aside from that, you'll be able to use the HDPF or the cementitious grout to otherwise support that entire section. Once again, after you take a look at the piping that surrounds the swimming pool. Very, very, very important to handle it with that. So that's really it. Again, swimming pools are the same things as houses. They've got all of the same problems, but it also has the unfortunate disadvantage of having the exposure to exterior elements like rain and washout and all the other fun stuff that you have there too. Plus, generally, it's closer to that slope and more subject to the slope creep. So evaluate the issue and make sure you know what you're proposing or what somebody's proposing to you. Once again, as the theme of literally every video that I've told you guys, start with an engineering report. Start with the civil, get some soils testing done, and make sure the proposed repair system is going to take care of the issue that is actually adversely affecting the structure that you're trying to stabilize. That's about it. If you guys have any questions, comments, concerns, drop a line below or private message me directly. Please like, share, follow, and thank you everyone so much for your patience. I will talk to you guys later. Have a good one.